Okay, this is question 3 of exercise 6.2. So in question 3, you are instructed to draw and clearly label the forces on the free body diagram for each of the blocks shown below. So first you have blocks at rest. If the blocks are at rest, that means the whole system is in equilibrium. Okay, that means A should experience a F net equals to 0. Similarly, B also experiences F net equals to 0. Okay, let's look at body A first. Now, body A over here definitely has its own weights pointing in the downward direction. I'll call this WA. Okay, so since it's in contact with B, so we'll draw at the contact surface a normal contact force which is perpendicular to the surface. Okay, you'll point away from the surface towards A. Okay, so away from the surface, this is the direction of the normal contact force. Okay, since the body is at rest, the upward vector, normal contact force, must be equal in magnitude with the downward vector, which is the weight. Okay. In free body diagram questions, when the question asks you to clearly label the forces, you are expected to spell out the forces in full. Okay, so please do not just leave them as N and WA. Okay, if you want to use symbols, then make sure you give a legend. Okay, so in this case, this is N1. That's a normal contact force by B on A. And there's a weight that I draw from the center of gravity of A pointing in the downward direction. I'll call this WA. And I support my free body diagram with the legends. Okay. Now you go to body B. Okay. When you are looking at object B, again, object B over here definitely will have its own weight. It points in the downward direction. Okay, and originates from the center of gravity. And because it's in contact with the surface over here, there'll be a normal contact force away from the surface. Okay, pointing towards B. Okay, so away from the surface into B. Okay, this is my normal contact force. At the same time, it's also in contact with body A. This is a contact surface. So you draw a normal contact force away from that contact surface towards the body. Okay, so it's in this direction. So now let's go and label all these forces. Okay, I'm going to call normal contact force by A on B as N2. Okay, so N2 is in this direction, vertically downwards. Okay, in fact, actually N1 and N2 should have the same length, okay, because the action-reaction pair. One is by B on A, one is by A on B. Next, you should have the weight of B also pointing in the downward direction. Let me just straighten my N2. Okay, and then you should have normal contact force by the surface on B. Now, take note, if the whole thing is in equilibrium, then F net should be equals to 0, which means that N3 okay, should be equal in magnitude to N2 plus WB. Okay, so that the upward force equals to the downward force. So when you are drawing, as much as possible, try to balance okay, the length of N3 with the total length of N2 and WB. Okay, so it should be about this long. I'll call this N3. Okay, and support your free body diagram with the corresponding legend. Okay, next, the blocks are being pulled towards the right. Now, if it's a rough surface, then on the surface, along the surface, there should be friction. Okay, again, let's look at body A first. There will be the weight pointing in the downward direction, normal contact force in the upward direction. Okay. If it's a rough surface, friction will tend to oppose the motion. Okay, so if it's being pulled to the right, friction will be pointing towards the left. At the same time, there's a string over here that is connecting A and B. Okay, so in strings, you always have tension pointing away from the object. That's the tension. Okay. So now let's label all the forces clearly. Okay. NA is normal contact force by surface on A. WA is the weight of A. So I'm going to label them as such. This is WA and this is NE. Okay, two of them are equal in magnitude, opposite in direction. So there's no F net in the vertical direction. And then there's a tension towards the right. I call this T. Okay, and friction along the surface. Okay, I'll call this F on A. Now let's look at body B. Body B, here again, will have its own weight pointing in the downward direction and normal contact force in the upward direction. Okay. Now, since it's connected to the same string over here, okay, B will experience a tension in the opposite direction and equal in magnitude. Okay, so in this case, if A experiences a tension to the right, B experiences a tension to the left. Okay, so this is the same tension as in same magnitude, opposite direction. B is still on the rough surface, so B will also experience a friction. And there is this force, okay, that is pulling box B towards the right. Okay, so free body diagram, there will be the force F, okay, that was drawn in the question. And on top of that, there will be all these forces that we have labeled over here. Okay, so weight of B, normal contact force by the surface on B. Okay, the tension that is away from B, okay, as well as the friction, okay, which is opposing the motion. Okay, so check that these two T have the same length.